Hello and welcome to a new video. As you see here, in this video, I'm going to talk about the chain rule and the implicit differentiation. First, I'm going to talk about the chain rule and later the implicit differentiation. Before I get to the chain rule, I'm going to give you some theorems that can tell you or make you understand the concept of the chain rule or how you can use it or solve it, okay? So, let's start here. The theorem number one, it's here is the th, means the theorem. So the theorem number one, let's say that you have a function z is equal to f x comma y, okay, and you have also x is equal x of t, and also you have y is equal y of t. What does this theorem means? It means to solve this chain rule, you have you have a equation, and the equation it can be written like this: dz over dt is equal to dz over dx times dx over dt plus dz over dy times dy over dt. So to make you understand why all of these variables and stuff, I I'm going to draw a diagram for you to understand how this all came up here. So let's start with the z. Okay, z here is consists of two variables. Okay, x and y. What about here x and y here? They consist of one variable, which is the t. So to solve the chain rule, dz with respect to t, okay, here let's make some new color. Here you have dz over dx, and here, because this z is going this way and z also can go this way, so here dz over dy, and also here the x is going towards the t, so you have dx over dt, and here the y also is going this way, so you have dy over dt. So which means you have to solve four things or four equations, you can say, so you can find the chain rule. Here dz over dx and dz over dy, this means that you need to take the partial derivative from the original equation with respect to x and with respect to y. And then the other two functions, dx over dt and dy over dt, you need to take the partial derivative for this equation, for example, with respect to with x, you need to take its derivative with respect to t. And also here the y is the same. And yeah, this is it. The second theorem, it's kind of the same, but the z, it consists of three variables, not with two. So this is the only difference. So let me make a diagram for you also again, so you can understand how it comes. Okay. Uh, let's make some space here. Okay. Let's say, let's name, yeah, let's make it or change it, for example, change this name to z. to, for example, W or anything, not always Z. It can be changed. And let's say, for example, this W function called W, it consists of three variables. And let's say also, for example, X is equal X of t, and Y is equal Y of t, and also Z is equal Z of t. So to find this bunch of equation, or to find the dw over dt, let's draw a diagram to know how you can get to the all equations, okay? So let's start. Here we have a w, and w consists of three variables, x and y and z. And also the x here consists of one variable, which is the t, and y is also has only one variable, and the z is the same as you see here. Then the w can go to the x and also to the y and also to the z. So we can write dw over dx, and also here to the y dw over dy, and then here dw over dz. Here x goes to the t, y also goes to the t, and z also goes to the t. So we can write it as dx over dt, dy over dt, and dz over dt. So we can start with the x, for example, first. We can say is equal. We write dw over dx, which it's the partial derivative of the original equation with respect to x only. Remember that. Times dx over dt. It means you take the uh, the equation that has x with respect to t, you take its derivative, and yeah, with respect to t, don't forget. Plus, we finished the x way. Let's go to the y way here. So we write dw over dy times dy over dx. Let's continue here. And then the last way, the z way, we can call it, we write dw over dz times dz over dt. Yeah, and this is it. This is the theorem number 2. It has a 3 variables, not only with 2. Yeah, the last um, the last theorem I'm going to talk about, it's kind of the same, but the difference that you might have is with the, not with the original function, it's with the normal functions that consist with the respect to t. Let's say, for example, we have a function called w. It consists with x and y only, for example. Okay, where is the brush? And let's say that you have an x here is equal x to the x of t, and you have not only one variable, you might have two. So this is the third theorem talk about. Let's say x of let's change the variable name, for example, not only t. Let's write, for example, um, r and s. See, the two theorems that I told you, it consists only with t, which means one variable. But this one talks about with two variables, or maybe more. It depends on the question that you get. And let's say, for example, y is equal y of r and s. So the question tells you, for example, for example, find dw over dr and find dw over ds. It might happen. So let me explain how you can write it in a good way. Always don't forget, always start with the chart. You have to draw the tree diagram, you can call it. So let's say that we have a w consists of two variables, x and y, okay? And here the x consists of also two variables and the y also. So here you have r and s, and y also here consists of r and s. If let's say, for example, if you want to find first the dw over dr, okay? dw over dr. Let's start with the r. So as you see here, the w goes to the x, and then x can goes to the r and s, but we want the r, so we will take the r way. And w can go to the right side, to the y, and then I want it to go to the right, so it can goes to the r. So we can write, let's change the red to black. We can write dw over dx, and here dx over dr, and here dw over dy, and here dy over dr. From here we can write them. dw over dr is equal to dw over dx times dx over dr plus dw over dy times dy over dr. And this is how you can find the dw with respect to r. But let's say, for example, if you want to write it with respect to s, not with r, dw over ds, for example, it's not going to change a lot. We can write it as um, we can write it as dw over dx, because the w here goes to the x. Now I want to take the s way, so times dx over ds, and then plus dw over dy, and then times dy this is a y, then over ds. Yeah, and this is it. Let's start with the first example. Um, okay, let's start with example number 1. The example number 1 said z is equal to the square root of x squared plus y squared. And he told you that x is equal to the e to the 2, this is a 2, 2t. And also said that y is equal to the e to the minus 2t. And, and the question wants you to find, he said find dz over dt. So from this diagram, we understand that z consists of x and y, and x here variable consists of t variable and y also has a t. So x has a t and y also has a t variable. So to write the uh, to write the equation in a good way, we need to write dz over dt, and then we say dz over dx, here dz over dx times dx over dt, dx over dt, and then plus dz over dy, and then times dy over dt. Yeah, this is the perfect equation to solve this answer. But what we need to find right now are the partial derivatives and everything we need to find. Right now, we will find the dz over dx and the dx over dt and dz over dy and dy over dt. So let's find them first, one by one. So starting with the dz over dx, dz over dx. So from this original equation, we need to find the partial derivative with respect to x. So here we have a square root, so we can write it as x squared plus y squared over 1 over 2, or to the power 1 over 2. Then equal, we can write it as 1 over 2 x squared plus y squared to the minus 1 over 2, because this is a power rule. We say 1 over 2 minus 1, so it becomes minus 1 over 2. And then we multiply it with the derivative of the inside. The derivative of the inside is with respect to x. So what's left here is 2x. Okay? So from here we can write it as, here we have a fraction. We can put the 2 down, and then here in this parenthesis we have negative 1 over 2. So if we flip it to the bottom side, it can be a positive number. So we can write it as a square root x squared plus y squared. And then we have at the top, we have 2x. We can cancel 2 by 2. So what's left here is x over square root x squared plus y squared. Yeah, and this is the final answer for the first thing. So let's put, let's select, let's put this answer, for example, let's put it right here. Let's find right now the dx over dt. So starting with this equation said that x is equal, we don't have to write it again. It said x is equal e to the 2t. So we need to find the derivative with respect to t. So the answer for this equation uh, is e to the 2t, and then we take the derivative of the inside, or in the power rule we take its derivative with respect to t. So the derivative for the 2t is 2, so the answer is 2e to the 2t, and this is the answer for the second equation function. Let's put it right here, for example, and the let's solve dz over dy. So we need to find the partial derivative from the original function with respect to y, not with respect to x. So solving, we solve it x squared plus y squared to the 1 over 2, and then is equal 1 over 2 x squared plus y squared to the negative 1 over 2. And right now we take the derivative of the inside with respect to y. So x squared with respect to y is a 0. What's left here is 2y. We flip negative 1 over 2 to the bottom, and 1 over 2 is also the 2 in the bottom, so what's left at the top is 2y. We get 2y over 2 to the square root x squared plus y squared. We can cancel the 2's, so what's left here is y over square root x squared plus y squared. Yeah, and this is the final answer. So I'm going to delete dz dx and this answer. Let me take this and put it right here, and I put it also right here. Okay, so come on. Sorry, I took too much time. Okay, that's okay. So the last variable that we need to solve is the y. So let's solve y is equal e to the minus 2t. So let's take the derivative for this one. The derivative for the exponential function, it said that we write the same value, then times the inside. We take its derivative with respect to t. So minus 2. The answer is negative 2 to the negative 2t. Yeah, and this is the final answer for this equation. We can cancel this one. We write here the brush, we write here plus, and then multiplies negative 2e to the negative 2t. Yeah, and this is the final answer for this equation. Let's take the let's take the second equation or example. I mean, okay. The second example. The second example said we have a w is equal square root of x plus y squared over z, and said this is a square again, remember, and said that x is equal e to the 2t and y is equal t cube plus 4t and z is equal t square minus 4. And he told you to find dw, find dw over dt. He wants you to find dw over dt, okay? So let's write a diagram quickly to understand the concept of this equation. So we have a w here, and the w here consists of three variables. It has an x, and has a y, and has a z. X, y, and z. And x and y and z functions, they are consist only with one variable, which it's the t. Only the t. So from here, everything has become very easy. We write dw over dt is equal to dw over dx times dx over dt, and then plus dw over dy times dy over dt, then plus also dw over dz times dz over dt. It's really a long and it takes sometimes time, but yeah, this is how you can solve it. But when you practice a lot, you can solve everything quickly. Nothing will get in your way. So let's start here by solving the partial derivatives. So first, I'm not going to take a lot of time explaining because I think everything has become more easily. So right now, I'm going to find the partial derivatives with respect to x, y, and z first. So from here, I will take the partial derivatives first, okay? So just to let you know. So solving the dw with respect to x. Okay, that's fine. Solving the dw with respect to x. So here we have a square root of x. So we can write it as x to the 1 over 2. Here we have y and z, so they are zeros. It equal 1 over 2 x to the negative 1 over 2, and it's equal 1 over 2 square x. And this is the first partial derivative answer. dw over dy is equal, let's solve the y here. Here we have a square root of x. It's a 0. We can cancel it here. We don't need it. Plus y square over z. So we can write it as 2. The partial derivative with respect to y is 2y here with y. 2y over z. And that's the answer. The last answer, dw over dz. Here we have a square root of x. It also cancels. We have y square over z. So we can write it as y square times z to the minus 1 first. And then we take its derivative with respect to z. We minus 1, it goes to the front. It become minus, then y square, and then z to the power negative 1 minus 1. It becomes negative 2. And the answer can be negative y square over z square. And those are the answers. Oh, wow. Let's continue here. Okay, let's continue here. We need to find the partial derivative with x, the x with respect to t. So x, or we can write, yeah, the x answer. The derivative with respect to t here is 2e to the 2t. Here I write it the same and I take the derivative of the power rule. And then I find the y. The derivative here with respect to t is 3t square plus 4, and z is equal to 2t. Right now, we just need to fill in everything. Let's fill everything. Let's delete all those here. So, um, so first answer is the x, dw over dx, and then times 2t, 2e to the 2t, um, yeah, times, and then plus. After the plus, we have, why it becomes black? And then we have the dw over dy, and then times 3t square plus 4 here times, and then we have a plus here also again, and we have the uh, negative y square over z square, and then times the 2t. We have times 2t. Yeah, this is the final answer for this equation. One last thing you can do, The equation here told you that x is equal e to the 2t, y is equal t squared plus 4t, and z equal t squared plus 4. One last thing you can do here is that every x, y, and z with the final answer, you can substitute it with the x, y, and z from the original function. So it can be written here also, sorry, don't forget that the 2's can be cancelled. You can write it here as e to the 2t here over square root of x. Here's square root of x. It can be substituted by the x from the original equation, e to the 2t, and then plus, here we have 2 times y. The y here is t cubed plus 4t over z. The z here is t square minus 4, and then times 3t square plus 4, and then minus, we have fraction y squared t cubed plus 4t, and then squared, and the z square, it also can be written as t square minus 4 squared times 2t. Yeah, and this is the final answer for the second equation. The last example for the chain rule that I'm going to give you, it's very simple, and also you can pause the video to try it, or yeah, it can be better for you if you try. If you find anything maybe hard or something, you can contact me. That is really okay and fine with me. So let's start. The example said that z is equal to cosine, this is trig function, cosine x times y plus y times cosine of x. Yeah, and he gave you that, and he told you that x is equal to r squared plus 5, and y is equal to r minus 5 squared. This is a 5 squared. So what you need to do, you need to draw a diagram for the z. Z is consist of two variables. Cosine is a function. We need to use the variables. We have the x here and we have the y, and x and y are consist of only one variable, which is the r. And yeah, see, everything has become more easily. From here we can write that dz over dr, and then we can write it as dz over dx times dr, sorry, dx over dr plus dz over y times dy over dr. This is the first step. What you need to do right now here, we need to find the partial derivative for the z with respect to x. So the derivative of the cosine is negative sine, and then x and y, x times y, and then times the inside. What's the derivative of the inside with respect to x is y, then times y, plus the derivative of the cosine here is also minus negative sine, so it's gonna be minus here, negative sine, x, and the derivative of the inside is the same, or 1, so we have nothing to write. This is the first value for dx over dz over dx. Then we find the dx over dr from here, dx over dr. So the derivative of the r squared with respect to r here times is 2r. Yeah, and this is it. Let's take from the original equation the partial derivative with respect to y. The partial derivative with respect to y is negative sine x times y times x. Here I took with respect to y, here is 1. What's left here is the x of from the inside function. Then negative also, uh, we're taking with respect to y. So negative x, sorry, negative sine x plus, yeah, sorry, there is a plus cosine of x, because with respect to y, so the y here is equal to 1 and the cosine is must be the same. Yeah, then multiplies with the dy over dr, this equation. The derivative of the r with respect to y, with respect to r is 1. So you can combine them here, combine them together, and this is the final answer. So let me give you like 1 minute an introduction or some equations that you can take from the equation, or the original equation you can say, or definition. It said that, for example, suppose that f of x and y is equal to 0. Normally, every equation we need to find using the implicit differentiation way, we equal it always with 0, whether in calculus 1 or here. We need to equal it to 0 first because it defines as a function of x. So that's why it's called implicit differentiation. So if we let for example x is equal to t, okay, then f of x comma y, this is an x, then comma y is gonna be equal to 0. And then it said, for example, where x is equal to t, y is gonna be equal to f of t. Okay, and then by the chain rule and everything is a blah blah blah, we don't need to hear it, we just need the equation that you need to find to use it to solve the equation. So it said that df over dt is equal to df over dx times dx over dt, and then plus, this is not a plus, this is a cross, okay, plus uh, df over dy times dy over dt is equal to 0. So you actually use the chain rule using the implicit differentiation in the partial derivatives. But what you need to know, this dy over, sorry, not a y, df over dy times dy over dt is going to be equal to the implicit differentiation is dy over dt, which it's equal that we really need is negative f of x over fy, which means every question you get to find the implicit differentiation, first thing you uh, equal the equation with 0, and then you take from the top, at the top of the fraction, you find its partial derivative with respect to x, and at the bottom in the denominator you find the partial derivative with respect to y, and this is it. Let's take example. I'm going to give you 2 examples because it's really easy. Let me give you the first example. It's not that hard. It said that y to the 5th plus x squared times y cube is equal to 1 plus y times e to the x square. Okay, and he told you, for example, find dy over dx. So first step that you need to write is f of x comma y is equal to y. You write the original equation but moving the right side to the left side, so you can equal it with 0. Y to the fifth plus x squared times y cubed negative 1 negative y times e to the x squared is equal to 0. This is the first step. The second step that you need, you have to write dy over dx that the question need here. You say negative f of x over f of y. So from here, the second step, you need to find its partial derivatives with respect to y or x. And remember, this question contains two variables, but maybe some questions you might have, it may consist with the three variables, for example, x, y, and z. And the next example, it's going to be with z, so you can understand how you can deal with three variables, for example. Okay, so dealing with partial derivative with respect to x first here, let's make a fraction. Here there is a minus, dealing with the fraction. Here y to the fifth is going to be 0, dealing with x. Here is going to be 2x times y cubed, negative 1 is 0, and then negative y e to the x square. The derivative of the x square is 2x. It's going to move here, times y, and then e to the x square. Then over fy, here is going to be 5y to the fourth plus 3x square times y square. Negative 1 is 0, and then negative y is going to be 1. What's left is e square. Negative e, sorry, to the x square. Last thing but not least, you can take a partial fraction or a common numbers. You can take them out of the parentheses, which they are the 2x and y from the top. 2x times y, you can take them out and you can write it as a negative y square, square, and then plus e to the x square, and then over here is gonna the same value, nothing is going to change. Yeah, and this is the final answer for this implicit differentiation problem. Let's take the last example that contains three variables. It said that if y times z to the fourth plus x squared times z cube is gonna be equal e to the x times y times z. Okay, and he told you that find dz over dx and dz over dy. Okay, so let's start. First step that I told you, we need to write f of x comma y comma z is going to be equal to y times z to the fourth plus x squared times z cube negative e. I took the right side to the left side. I took the e to the left side. E to the x y times z is equal to 0. This is the first step. It's easy. The second step that you need to write, let's find, for example, first dz over dx. So we write dz over dx, and then it's going to be equal negative f of x 2 or sorry over f z. This is how you can solve it. Now you just take the partial derivative with respect to x and with respect to z, and yeah, you can solve it. Let's solve it together here. Taking with respect to x here, yz to the fourth is 0. Here x is going to be 2x z cube, and then negative x times y times z. We take its derivative of the power is going to be negative y times z, then e to the x times y times z. And then over, we find with respect to z here, 4 we take it to the front, 4 times y times z cube, plus 3 we take it also to the front, 3x square times z square, and then negative. We take the c out from here because its value is 1, with taking with respect to y for the e. What's left here is x times y, e to the x times y times z. Last thing, we can take a z out from here. We can take a z. So what's gonna be inside is y times e to the x y z times z negative 2x and then z square, and then over the same answer is gonna be here. This is the answer for the dz over dx. You can find or try to solve dz over dy as a homework for you, or you can make it as an exercise for you, so you can try and see what the answer comes. Yeah, thank you for watching, and I hope everything was really easy, clear, and obvious. uh, I hope all the ideas has become more easy and nothing uh, make you confused or something. شكرا على المشاهدة. بتمنى كانت كل الأفكار واضحة وكل شيء كان واضح، وبتمنى ما يعني ما يكون في صعوبة ببعض الأمثلة. يعني بتمنى إنه كان كل شيء واضح، وفي حال مثلا ما حدا آه، حس مثلا بصعوبة أو شاف في هيك صعوبة الاستيعاب مثلا أو هيك، ما في مشكلة. فيك إنك ترسل لي على إيميلي يلي راح يكون بالديسكريبشن، وبنفس الوقت فيك تكتب بالكومنتات الشيء اللي ما فهمته وما فهمته، وإن شاء الله أنا راح أحاول أعيده أو بعطيك أمثلة زيادة، ما في مشكلة. Thank you all for watching and see you in the next video. Thank you.